Hello and welcome. You should be on page 20 of your quarter 2 Algebra 1 notebook. In this video, we're going to talk about graphing linear inequalities. So, when graphing linear inequalities, there are a lot of things I need to do. The first step is to decide if the line is going to be solid or dotted. When I have the less than or greater than symbol, I will have a dotted line. A dotted line means that all ordered pairs on the line are not solutions to the inequality. So that's really important. Any point on the line is not a solution. For less than or equal to or greater than equal to, I will use a solid line. And this means that all ordered pairs on the line are solutions. So if you think about inequalities in general, the dotted line is like that open circle. That number didn't count, whereas the solid line is like the closed circle. You then have to decide on the appropriate method of graphing. You might use intercepts if you find that you have a line in standard form, or you might use slope-intercept form if you have a line that can easily be written as y equals mx plus b. You should graph the line with dots or solid. Using a ruler for precision is great. And then you need to shade appropriately. And this is where I wish this had been updated in the notebook, because we are going to just cross that out. And I'm going to write use a test point. So we're going to use a test point rather. Here's how it goes. Sorry, you're going to see that I had to erase that and rewrite it so it was a little more bold. So you need to choose a point, so an x and a y, that is not on the line. The key about that, if possible, or whenever possible, choose 0, 0. So if a line does not cross the origin, use the origin as your point. And now this is all going to be erased. And what I'm going to do is think about this for a few seconds and pause it, then I'll come back. So I just crossed out that, and I'm going to write if the resulting statement is true, you shade the test point. So if you end up with like 5 is greater than 0, that is a true statement. So your test point will be shaded. If the resulting is false, you do not shade the test point. That's a little sloppy, but guess what? I will show you. So here we go. Let's look at number 1. Y is less than 1. This is going to be the one exception where I'm not going to use the intercept or the slope intercept. I'm going to kind of use that table of value methods because I've got a horizontal or vertical line. But is the line solid or dotted? Well, it's a less than, so it is going to be a dotted line. I'm just going to do a really quick table of values here. Y is 1, 1, 1. Let's have x be negative 3, 0, and 3, just to kind of give me a little bit more points. So I have x is negative 3, y is 1. X is 0, y is 1. X is 1, 2, 3, y is 1. So I know this is going to be a dotted line, so I'm going to put some dots like this. And now I need to think about my shading. So I'm going to use a test point. I can see that 0, 0 is not along the line. So I'm going to use 0, 0. So I'm going to use 0, 0. That tells me that x equals 0 and y equals 0. So I'm going to substitute this into the equation. Well, I don't have an x, so I'm going to write is 0 less than 1? Y is less than 1. I substituted the 0. Is that a true statement? Yes, 0 is less than 1. So I'm going to shade 0, 0. Here's 0, 0. It's part of the shading of this particular linear inequality. So what I want you to note is that any point here is a possible solution. Linear inequalities have many solutions. Choose obvious solutions. In other words, points that are clearly in the shading region. Note, on this linear inequality, any points along this line are not solutions, but I know that 0, 0 is a solution. Let's do this one. This is at 1, negative 1 is a solution. How about this over here? This is at negative 1, 2, 3, 4, negative 1. And yeah, that's it. 3 is enough. Now let's take a look at our next example. Is the line dotted or solid? Well, it's less than or equal to, so I'm going to have a solid line. This looks like standard form, so I'm going to use the x and y intercept. So first I'm going to have x equals 0. There's going to be my y-intercept. So if x equals 0, I end up with negative. When I'm finding my intercepts, I'm just going to make them equations. So I'm going to have negative y equals 4, and that is going to result in y equaling negative 4. So even though this is an inequality, when I'm finding the intercepts, just pretend that's an equal sign. So at 0, negative 1, 2, 3, 4. Now when y equals 0, so my x-intercept, I'm going to minus 0, so I will end up with 2x equals 4, and this will result in x equaling 2. So there is the line. It's a solid line, so I will draw a nice, clear, solid line. Oops, I don't want to go into my possible solutions box here. And now I need to think about the shading. So again, I'm going to use, so if I have 2x minus y is greater than or equal to 4, I'm going to use 0, 0 because it's not in here. So I'm going to substitute 0 in for x. 2 times 0 minus 0 in for y. Is that greater than or equal to 4? Well, 2 times 0 is 0 minus 0. Is that greater than or equal to 4? Is 0 greater than or equal to 4? Indeed, it is not. That is a false statement. So I will not, do not shade 0, 0. Here's 0, 0. So this shading of this particular inequality is like that. Alrighty. Let's talk about some points. Well, this is a solid line, so both of my intercepts are solutions. So this is at 2, 0, and this is at 0, negative 4. And then I can find another point in here. Let's make another point. Haha. 1, 2, 3, negative 2. And there you go. Let's go to the next page and see what we've got. So we have 2 more examples. What I'm going to do is let's kind of determine some of the elements, and then you can try these on your own. This is going to be using slope-intercept form. So I know that it's a greater than, so it's going to be a dotted line. B equals 4, so I can plot that at 1, 2, 3, 4. And M equals negative 3. Put that over a 1, so I will go down 3, right 1. Down 3, right 1, down 3, right 1, down 3, right 1. Dotted line. Here we go. And I'm going to just remember that because it's a dotted line, all the points I've just graphed are not a part of the solution set. So when I use my test point, I can see that 0, 0 is not there. So if y is greater than negative 3x plus 4, I'm going to use 0, 0. I'm going to substitute 0 in for y. Negative 3 times 0 plus 4, 0. That's 0 plus 4. Is 0 greater than 4? Well, that is indeed false, right? That's not. So 0, 0 is not shaded. So this particular line will be shaded up here. Alrighty, let's take a look at this one. Standard form, so I am going to use my x and y intercept. This is again going to be a dotted line. And what I want to do is I'm going to say x equals 0, 0. So I'm going to be on the y-axis. This gives me 1/2 y equals 1, and that is going to result in y equaling 2. So when x equals 0, y will equal 2. Now if y equals 0, or my x-intercept, I'm going to get 1/4 x is less than 1. Multiplying by the reciprocal is going to result in x equaling 4. So 1, 2, 3, 4. And now I have to update this later. I am going to give myself a nice dot. I'm just going to make that arrow a little bit better. And dot this line here. Dot, 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 arrow, arrow. So again, these are not solutions. Let's do our test point. Is 0, 0 shaded? No. So we got a test point. What I'm going to do is write 1/2. We're going to use 0, 0. Times 0 plus 1/2 times 0. So I substituted 0 is less than 1. 0 plus 0 is less than 1. Is 0 less than 1? Sorry, that should have been a 1 here. Well, indeed it is true. So shade 0, 0. So this is shaded down like this. So all of these points are solutions. So let's get some examples of solutions for both of them. I'm going to have a solution here, a solution here, and a solution there. This solution is at 1, 2, 3, 1. This solution is at 1, 2, 1, 2, 3. And this solution is at 1, 2, 3, 4, 5, 1, 2, 3. For these, let's have 0, 0. That makes that nice. Let's have this solution, 1, 2, negative 1. And we'll go here, negative 1, 1. And that is it for this video. I am going to have a very short video where we do number 5 on page 21. Thanks so much.